Welcome dear friends. Good afternoon. This is a series of lecture for analytical chemistry TY based students, and in this video this is a part 4 chapter number 3 thermal methods of analysis. We are going to learn about some basic concept in the chapter of thermal methods of analysis. The topic is basic before to learn instrumentation in thermogrammetry. Now there are some basic parts involved in thermogrammetry, and before going to learn about the instrumentation, some basic concepts are related to thermogrammetry and we have to learn them. Thermogrammetry is of three types. Now there are three types of the thermogrammetric analysis: isothermal or static thermogrammetry, quasi-static thermogrammetry, and dynamic thermogrammetry. Now the isothermal, static or static, there are one and the same meaning: isothermal or static thermogrammetry. Now the dynamic thermogrammetry is also called as a non-isothermal thermogrammetry. So we are going to learn about some basic concepts like definitions of branches, or you can say types of thermogrammetry. First is isothermal or static thermogrammetry, the type in which the sample weight is recorded as a function of time at constant temperature. Now in an isothermal, you can say the name itself, there is a constant temperature, isothermal. The type in which the sample weight is recorded as a function of time at constant temperature. Now at the y-axis there is a sample weight, and at the x-axis there is a time, but the condition is at constant temperature. The type in which the sample weight is recorded as a function of time at constant temperature. Now the next one is quasi-static thermogrammetry. Now the type in which the sample is heated to constant weight at a series of increasing temperature. Now there is a series of increasing temperature and sample is heated at constant weight. Now at constant weight is constant, but the sample is heated. The sample is heated at constant weight, to them a series of increasing temperature is given. Now the next one is, the third one is dynamic thermogrammetry. As I have already said, the dynamic thermogrammetry is also called as a non-isothermal thermogrammetry. The temperature in which the sample is heated in an environment where the temperature is changing predetermined fashion. Now here the temperature in which the sample is heated, no doubt sample is heated, and you can say the temperature is changing in a predetermined fashion, but here is a monitoring possibility is done about the temperature. So the temperature in which the sample is heated in an environment, but in that environment temperature is changing in a predetermined fashion. We have the authority, we have the guidelines about how to temperature is controlled. Now here isothermal gravimetric or static gravimetric and non-isothermal, or can say dynamic gravimetric, are the important modes of operation. The TG, that is the TG means thermogravimetry, is an open system. The curve representing the change in weight versus temperature is called as a thermogram. So here the basic definition of thermogram. Here the curve, we can say the graph in which at the y-axis there is a change in weight, at the x-axis there is the temperature, and this graph is plotted. That is nothing but a thermogram. So thermogram is nothing but it is a graph of, we can say, change in weight with temperature. Thermogram gives the quantitative information for thermal stability and composition of the initial sample. So thermogram, now here is a typical thermogram. Is in this way we get the curve, we can say, and this thermogram gives the quantitative estimation about the sample, or you can say thermal stability for the sample and the composition of the initial sample. So what is the composition of the initial sample and what is the thermal stability of the initial sample? Both are determined with the help of thermogram. Now, what is the application of thermogrammetry? What is the application of thermogrammetry? Thermogrammetry is basically useful in organic chemistry as well as the inorganic chemistry, no doubt. So here, for the inorganic chemistry, it is useful in the field of minerals, ceramics, metals, alloys, carbides, glass, catalyst, construction materials. So these are the all you can see inorganic material. So thermogrammetry is useful organic for the useful in in case of inorganic material as well as the organic material. So organic material are drugs, plastics, explosives, detergents, dyes, fibers, fuels, polymers, composites, and soft materials. So synthetic fibers we can say useful. So thermogrammetry is useful in case of inorganic chemistry as well as the organic chemistry, or you can see inorganic materials as well as the organic materials. Now, many factors affects the reproducible TG curve. So, in the thermogram, we can say we get the TG curve. The TG curve is also regarded as a thermogram, no doubt. But what are the factors affecting the thermogram? We can say what are the factors affecting thermogrammetric curve? What in the thermogram we get the curves, and these curves are called as the thermogrammetric curves. Now here, heating rate, nature of heating, rate of recording curve. Now heating rate, what is the if heating rate is given to the sample. Next one is nature of heating. What should be the nature, whether fluctuations are occurred in the heating or not. So that is nature of heating. The third one is rate of recording the curve. So what type of recording system is applicable for the, you can say, deciding the rate. Next one is furnace atmosphere. If the furnace atmosphere is also affects the reproducible TG curve, because in the furnace atmosphere we have already studied that oxygen is present, and this oxygen is responsible to produce to give the oxides of the, you can say, non-unwanted oxides are obtained in the furnace in the inert atmosphere, you can say the nitrogen atmosphere, and this affects the TG curve. Now the next one is composition of sample container. Now the composition of whether the sample container you can say small or large, so that decides the you can say TG curve. Next one is geometry of the sample holder. So geometry of the sample holder is also affect the TG curve. Sensitivity of the balance. So which type of balance we are going to use that decides the you can say TG curve. Recording mechanism. So recording mechanism like spirometer, you can say, useful for the, you can say, in deciding the reproducibility of TG curve. Now these are the all factors affecting the reproducible TG curve. You can say heating rate, nature of heating, rate of recording the curve, furnace atmosphere, composition of the sample container, geometry of the sample holder, sensitivity of the balance, and recording mechanism. Now here, nature, particle size, quantity, thermal conductivity, and specific heat of sample are the sample characteristics affects the rate of decomposition. Now here, decomposition temperature is also, can say, useful to decide the reproducibility of TG curve. But in that rate of decomposition, we can say rate of decomposition of temperature also affects the reproducibility of TG curve. So for that, sample characteristics. So which are the sample characteristics? First is that nature of the sample, particle size of the sample, quantity of the sample, thermal conductivity of the sample, specific heat of the sample. So all these are the factors affecting the rate of decomposition temperature. These are the sample characteristics. So with this content, I conclude this lecture. Thank you very much for your patience listening. I again request to all my viewers to subscribe my channel so that I emulate for my work, and I will give the next series of can say analytical chemistry lectures. With this content, I conclude this lecture. Thank you very much for your patience listening.